My name is Roger. I've spent the last 28 years working for the Church of England. I am a bishop, which is kind of like an area manager, only in fancy dress. And I look after the churches across North Essex. My job this afternoon is to set the scene. And the first thing to say, which sounds like the kind of thing an actress might say to the bishop, is, well, it's getting hot in here. And I don't just mean that finally, after a few false starts, summer has begun to put in an appearance. No, I mean that the thing that we call global warming really is happening. Just take a look at this chart of global temperatures from 1870 on the left to the present day. Last year was the second warmest year on record. The chart shows not just that things are getting warmer, but that the rate at which the temperature is rising is also going up. The world is getting hotter quicker. The 10 warmest years on record have all happened since 2005. From 1900 to 1980, a new temperature record was set on average every 13 and a half years. From 1981 to 2019, a new record was set every 3 years. So what's causing this? Well, let's have a look at the science, and please bear with me if all this is a bit old hat. Here we are on planet Earth. Our main source of energy is the sun. During the day, we absorb energy from the sun, and during the night, as well as during the day, we reflect some of that energy back out into space. That energy, that sunlight, comes to us in a variety of wavelengths, ultraviolet, visible, and infrared. And all that light has to pass through layer upon layer of our atmosphere. And some of those layers absorb some of the light, and some of the layers allow the light to pass right through, and some reflect the light back out into space. All told, just over 3/4 of the energy from the sun makes it down to the Earth's surface when the sun is directly overhead. Now, depending on what the surface is like, whether it's water or sand or whatever, some of the energy is absorbed, some of the energy is reflected. And what we know is that just under 1/3 of the incident radiation from the sun gets reflected off the surface of the Earth. And just above 2/3, 69%, gets absorbed by the Earth. So when we put all these factors together, we can calculate what the temperature of the Earth should be. And the answer we get is on average -18 degrees centigrade, about the same temperature as the inside of your freezer at home. Now that's absurd. We know that that's not how it is, thankfully, because frankly, -18 degrees centigrade is a little bit chilly. Instead, our planet has an average temperature of around 15 degrees centigrade, much more civilized. Well, what's going on? The Earth is effectively wrapped in an insulating blanket that stops some of the heat that the Earth radiates from escaping. Just as the atmosphere did not let all of the sunlight through to the Earth, so the atmosphere also traps some of the infrared light from the Earth having warmed up that it now radiates. And because of its particular wavelength, there are certain chemicals, certain substances that will absorb that infrared radiation. And they are mainly water vapor, carbon dioxide, and methane. And it's these three gases in our atmosphere, along with smaller amounts of ozone, nitrous oxide, and so on, that act as a blanket trapping the energy that the Earth is radiating, just as a blanket or a duvet or a sleeping bag traps the heat that would otherwise escape from your body. And the thicker the blanket, then the warmer you will be. And you know that you wouldn't use a 13 or 15 tog duvet in the summer because that would trap in too much warmth and you'd overheat. And in just the same way as we've added to the amount of carbon dioxide and methane in the atmosphere, so that insulating blanket has got thicker and thicker, and we have got warmer and warmer. We talk about carbon neutrality and zero carbon, but really the killer, and I mean the killer, is carbon dioxide. When you burn stuff like wood or oil or coal or gas or petrol, the stuff combines with oxygen, and the two main products, as well as heat, that you end up with are carbon dioxide and water. as we keep belching out more and more carbon dioxide, so it adds to the levels that we already have and thickens still further the insulating blanket that wraps around the Earth. And that is why it's getting hot in here. So what? I mean, what are the knock-on effects of all this extra warming? The first thing to note is that water levels are rising. They're rising for two reasons. Firstly, it's the oceans that are absorbing more than 90% of the extra heat in the atmosphere. And as the seawater warms up, so it expands. But also, we are seeing land-based ice, such as glaciers and ice sheets, melt at an alarming rate. An area of sea ice, roughly 10 times the size of the UK, has been lost since the early 1980s. And the rate at which the ice is melting is going up and up and up, just like the sea levels globally. Almost 40% of the population of the USA live in densely populated coastal areas. And the sea level there plays a huge role in flooding, shoreline erosion, and various storm hazards. Globally, 8 of the world's 10 largest cities are near a coast. But what about Essex? Well, it's not looking good. This map from our friends at Climate Central shows that huge swathes of the Essex coast could be below sea level by 2050. I'm afraid that Canvey Island will be the first to go. Pretty much all of Tilbury and large parts of Grays and Purfleet could be underwater by 2050. Lakeside Retail Park would be no more, and the railway line from East Tilbury to Rainham and most of the A13 at Stamford-le-Hope would also be submerged, as well as half of Corringham. North Essex does not fare much better. Half of Mersey Island will disappear, and Brightlingsea will have become an island in itself. Of course, with rising sea levels, the risk of coastal flooding more than doubles in the same period. The risk of surface water flooding, as well as rivers and streams bursting their banks, also rockets. And yet, the floods that we are facing more and more often are mirrored by severe drought in summer. Hotter, drier summers mean Essex already suffers from water scarcity, and this pressure on water supplies will also increase year on year. It's just getting hotter. Look at the west coast of America. Now, this was only last week. I've been to Oregon, and this is not normal. In Oregon, they often talk about June as January because it's always so cold, but not now. And that's worrying. The Met Office predict that by 2100, under a high emissions scenario, the UK could see 40 degrees centigrade days every 3 to 4 years. If emissions are reduced in line with the Paris Climate Agreement, the future probabilities are expected to be considerably lower. Heat waves caused a record 2,556 excess deaths in Britain last summer, even as the country was struggling to contain the coronavirus epidemic. And as soil moisture levels continue to decline, so the need for irrigation goes up. And our seasons get all mixed up, so plants blossom before pollinators have hatched. And all this drives yields down. We saw that last harvest due to a warm and dry April. Catastrophically, we also face the risk of the degradation of our soil and of desertification. And it's not just the agricultural land that's at risk. The British Geological Survey reports that the hotter and drier summers mean that ground under houses will shrink and crack. That's because the clay formations underlying this part of the country are most vulnerable to losing moisture. And then, of course, there is our favorite topic, the weather. And we are already witnessing huge disruption to our weather patterns. Just look at what happened last week in Berlin and other parts of Europe. Just cast your mind back over the last 12 months. The UK experienced a brief spell of unusually warm weather at the end of March, with temperatures reaching 24 centigrade. That was followed by a cold plunge of Arctic maritime air in early April, bringing widespread hard frosts and some snow. Back last Christmas, Storm Bella was a large, deep area of low pressure in the North Atlantic, and it brought heavy rain and strong winds across the UK. Earlier in 2020, on October the 31st, Storm Aidan brought a spell of turbulent, wet and windy weather, which lasted to early November. At the start of October last year, Storm Alex had brought strong winds to the southern half of the UK, while on the 3rd of October 2020, that was the wettest day on record since 1891, with average rainfall of 31.7 millimetres across the entire UK. About a year ago, in August 2020, storms Ellen and Francis were two of the most notable August storms in the last 50 years, with gusts of 50 to 60 knots in exposed coastal locations. On the 16th of August last year, thunderstorms affected parts of East Anglia. Earlier in the month, temperatures had exceeded 34 centigrade across parts of the southeast for 6 consecutive days, with the overnight temperature remaining above 20 centigrade. And on the 31st of July 2020, the temperature at Heathrow Airport reached 37.8 degrees centigrade. We cannot go on breaking record after record. So what can we do? Well, quite a lot. Hence the work of the Essex Climate Action Commission. We need to stop adding layer upon layer of carbon dioxide to the blanket that is causing us to overheat. That's why we talk about zero carbon and the need for net zero carbon emissions by 2050. Climate change is already affecting us, and we need to take urgent action. The good news is that we absolutely can. We have the opportunity here to transform Essex, to open up the opportunities in moving to a low carbon world for our families, our farmers, and our businesses. We can build a better, cleaner, greener Essex. Thank you.